This is the video for Lesson 7.3, Defining and Using Negative and Zero Exponents. Now this is kind of a strange concept, so to start off, I'm going to give a little example of what's going to happen here. I'm going to write down 2 to the third, 2 squared, 2 to the first, 2 to the power of 0. I'm going to go into a couple of the negatives here. Now we can do the top half of this. 2 cubed is 8, 2 squared is 4, and 2 to the first is 2. Now let's look at what happens as we go from one number to the next. We could say that we're subtracting 4, but as we keep going, that's not the same pattern. So the other thing is to say we're dividing by 2, or the other option, the dividing by 2 is really the same thing as multiplying something by a half. And let's see if that holds true. 4 divided by 2 is 2, so that works. So now as we get to this 2 to the power of 0, we're going to continue this pattern and see what happens. 2 divided by 2 equals 1. So this brings us to the rule that anything to the power of 0 equals 1, which I know seems strange, but you just got to trust me on this. If we continue the pattern now into the negatives, divided by 2 again, 1 divided by 2 is a half. So 2 to the power of negative 1 would just be 1 over 2. If we divide that by 2 again, or multiply by a half, that equals 1/4. Notice 4 is the same thing as 2 squared. And if we go again, divided by 2, we get 1 to the 8th. And this would be the same thing as if I wrote it out as 2 to the third power. So the thing with negative exponents, I'm going to ignore this stuff here because I think that gets a little wordy, but a negative exponent just means that the base is on the wrong side of the fraction line. So you need to flip the base to the other side. So for our 2 to the negative first, we need to stick it down in the denominator. 2 to the negative second, we took that 2 squared but stuck it down in the denominator. So recap once again, anything to the power of 0 is 1. A negative exponent just means we're going to put it on the other side of the fraction and make it a positive exponent. So example 1. I want to start off by saying that in this lesson, when we simplify powers with numerical bases, we are going to evaluate the numerical power. I know that's a little bit different than what we did before. We just left it with an exponent. But in this case, your exponent shouldn't be too big. We are going to simplify it further. So for letter A, that base of 3 has an exponent of negative 2. All that means is we're going to take it and rewrite it on the bottom of a fraction. Notice our exponent then becomes positive, and we can say that that really equals 1/9. For B, be careful on this one. People get confused. Exponent first. So 7 to the power of 0, that would be 1, because anything raised to the power of 0 is 1, but we have that negative sign out front. Notice that that would be different if I put that negative 7 on the inside of the parentheses. Now, this to the power of 0, that would just be a positive 1. Letter C, 2 ways to do this one. 1/5 to the power of negative 2 means we take that 1/5 and rewrite it on the bottom. So 1 over 1/5 squared. That could also mean 1 over power of a quotient here, so 1 over 25. But 1 divided by 1/25 is the same thing as 1 times the reciprocal, and that would just end up being a positive 25. Another option, if you don't like that way, we can use this power of a quotient property we learned in lesson 7.2, and I say that equals 1 to the negative second over 5 to the negative second. The definition of a negative exponent means it's just in the wrong spot in the fraction, so I can rewrite that as 5 squared over 1 squared, and that would also just equal 25. Letter D, notice it's in the denominator now, but we're still just going to put it on the other side of the fraction. So we're going to pull it up into the numerator, and letter D equals x cubed. Another note, is if we have multiple things going on here, only the base with the negative exponent gets moved around. So in letter E, the only thing that has the negative exponent is this x, so that 5 is going to stay where it is. Okay, so we're going to create a fraction. This negative exponent moves it to the denominator, and that 5 is going to stay up top. Letter F, this whole thing has a negative 4, so I'm going to take it and rewrite it in the denominator of the fraction with a positive 4. And finally, tricky one, letter G. Let's see what happens here. If we have 0 to the power of negative 5, that would be the same thing as rewriting it in the denominator of the fraction. And hopefully we're realizing, hey, we can't have a 0 in the denominator of a fraction. This is undefined. Okay, so go ahead, pause the video, try your guided practice, and play when you're ready. Number 1, anything to the power of 0 is 1. Nice and quick. Number 2, this would be 1 over negative 8 squared, which equals 1 over 64. Number 3, it's in the denominator now. To get rid of that negative exponent, we pull it up out of the denominator, and that just equals positive 8. And number 4, remember we said only the base with the negative exponent gets moved. That 2 and that 5 are going to stay right where they are, and that x squared gets moved up to the top. And finally, number 5, negative 1 to the power of 0, that's 1. Turn your paper over. Okay. Not going to go through all of these again because we've learned them in the previous lessons. However, the properties of positive exponents we've already learned can be used with negative or 0 exponents. Okay, so that's what we're going to do now. So example 2, we're going to combine some things we've done before. Letter A, we have a base of 6. Okay, we have product of powers property. So we add our exponents together. So that would be 6 to the power of 0, because negative 4 plus 4 is 0. And 6 raised to the power of 0, that just equals 1. Letter B, 2 options. Okay, we can use our power of a power property first and say that this equals 4 to the negative 4th. Multiply your powers, which we can then say, according to a definition of a negative exponent, means we stick it down in the denominator. And then that would equal 1 over 256. Another option, okay, is to say let's switch this first. So we can say that that equals 1 over 4 squared, and then that's squared. Power of a quotient means that this would be 1 squared over 4 squared squared. So that would still be 1 over 4 to the 4th, and we still get 1 over 256. For letter C, this just pulls it up out of the denominator, so it's 3 to the 4th. That equals a positive 81. And letter D, once again, I'm going to give you 2 options. Okay, option 1, okay, I'm going to say quotient of powers property. So that means that since I have a base of 5, I'm going to subtract my exponents, and that'd be 5 to the, I'm going to write it out this time, negative 1 minus 2. Subtract your exponents. So that would really be 5 to the negative 3rd. That moves it to the other side of the fraction, so it'll be 1 over 5 to the 3rd. And that equals 1 over 125. Option 2, I'm going to call it negative exponent. Okay, so really looking at this, that 5 to the negative 1st is going to be flipped to the other side of the fraction. And that 5 squared is already down there. Now I can add the exponents together in the denominator, so that would be 1 over 5 to the 3rd. equals 1 over 125. Okay, so once again, multiple options for some of these. Okay, just go with what you feel comfortable with. So try your guided practice and play when you're ready. Number 6, 1 over 4 to the negative third. We're just going to pull it up out of the denominator. So it's going to be 4 to the positive third, and that equals 64. Number 7, I'm going to apply my power of a power. There's multiple ways to do this, but I'm looking at this and saying power of a power. So negative 3 times negative 1 is a positive 3. So that would just equal 125. Number 8, I see a common base, so I'm going to add my two exponents together. So I get negative 3 to the power of 0, which equals 1. And number 9, it's kind of like D, so there's two options of doing this. Okay, I choose to move my negative exponents first. So I'm going to stick that 6 squared down in the denominator with the other 6 squared. That's going to be 1 over 6 to the 4th. And if you multiplied that out, you get 1 over 1296. Example 3, putting it all together. Okay, notice they're getting a little bit crazier. Okay, but just go through your properties and you should be good. So letter A, I see a power of a product. So I'm going to do that first. Remember that cubed applies to every single thing on the inside. If you need to write out the steps, write out the steps, but I think some of us can jump right there now. So 2 cubed is 8. X cubed, we just write x cubed. And then y, it's going to be negative 5 times 3, so y to the negative 15th power. And now the only thing that has a negative exponent is my y, so that's the only thing we're going to send to the denominator. So we're going to have 8x cubed over y to the 15th. Letter B. Once again, there's multiple ways of doing this. However, I'm looking at this, I'm saying a negative exponent, I'm going to move it first. So I'm leaving that y to the 5th on top. I'm moving that 2x. Now it's going to have a positive 2 on it as an exponent to the bottom. And I'm going to rewrite everything else that's down there. Okay, this here I can simplify, so it's going to be y to the 5th. 2 squared is 4 times x squared. And then times negative 4 x squared y squared. Let's break it down piece by piece. I have a 4 times a negative 4. I'll deal with my coefficients. That's a negative 16. Look at my x's. X squared times x squared in the denominator means it's x to the 4th. And then y to the 5th over y squared. Subtract your exponents. That's y cubed. More y's on top. So it gets stuck in the numerator. And letter C, I'm going to move my negative exponent first. So I'm going to rewrite it as 3x over 9x cubed y from before, but then moving that y cubed down to the bottom now. I can simplify my numbers, my coefficients. Remember, when it comes to the coefficients, we're just simplifying them as the fraction. So that would be 1/3. X over x cubed. Okay, hopefully we can see that there's going to be 2 extra x's down here. So it's going to be x squared. The other way to think about that, if you're having trouble, really that's an x to the 1st. 1 minus 3 is a negative 2, and since it's a negative, we stick it down on the bottom. And then with our y's, we have a y times y cubed. We get y to the 4th. Okay, try the guided practice questions and play when you're ready. Okay, let's apply this cube to everything that's there. So 3 cubed is 27. X, we're going to have negative 2 times 3, so negative 6. And y, 2 times 3 is 6. This has the negative exponent. So we're going to send the x to the 6th to the denominator. Number 11, I'm going to move my negative exponent first. So I keep my 4y to the 4th up top. I'm going to rewrite my 8xy to the 6th, but I'm moving my x squared to the bottom. I'm going to simplify my 4 over 8. That's going to be 1 over 2. My x's, x to the 1st times x squared is x cubed. And y to the 4th over y to the 6th, there's going to be 2 extra y's at the bottom. And that's my final answer. Last example. The order of magnitude of the mass of a polyphemus moth larva when it hatches is 10 to the negative 3rd grams. During the first 56 days of its life, the moth larva can eat about 10 to the 5th times its own mass in food. About how many grams of food can the moth larva eat during its first 56 days? So we're going to take its mass, which is 10 to the negative 3rd. It says you can eat 10 to the 5th times that. So we're going to multiply that by 10 to the 5th. We have a base of 10, so we're going to add our exponents to get 10 squared, which means our answer is C. Nice and quick. Okay, that is the last lesson before the extension. Okay, well, we'll deal with some fractional exponents. Okay, but please make sure, once again, you write down any questions you have. Okay, because we're going to have a quiz coming up soon.